Hello everybody, today we're going to talk about arc length and sector area. So, arc length is the length s with a radius r and a central angle theta measured in radians, and is as follows. S is equal to r theta. So when you guys have a circle and you have a radius r and then you have an angle theta, this right here would be your arc length. So, if we want to find an example here, we have if r is equal to 7 inches and the central angle of a circle is 215 degrees, then find what the length of the arc that subtends the circle. So, just to give you guys a visual on what this looks like, we have a circle and we have a radius of 7 inches. The central angle is 215 degrees, which makes it quite big. So we have our angle, which is theta, of 215 degrees. Okay, and we want to find the length of this arc right here. Now there's something super important when we are doing this formula. Theta has to be in radians. So we have 215 degrees here, so we actually have to convert that into radians by multiplying it by pi over 180. Okay, now when we do this, we're going to get 215 pi divided by 180. Now when you put it in the formula, you can actually leave it like this. I like to reduce when possible, and when you reduce this, you're going to get 43 pi over 36. Again, you don't have to reduce because we're just about to stick that into another formula. So we have S is equal to r theta, and we're looking for S. So we have R, that's 7 inches, and we have theta, which is 43 pi over 36. Again, you could just put 215 pi over 180 in here. I'm not going to judge. So what you're going to do is you're then going to put this entire thing directly into your calculator. Okay, and you're going to round it to the nearest tenth of a degree, tenth of an inch. So when you do, you're going to put that in your calculator, you're going to get 26.3 inches. Please do not forget your units. How do I know it's inches? Because if you look back over here, the radius is measured in inches. So that means our arc length is also going to be measured in inches. So let's try another one. Suppose the central angle theta is equal to 5 pi over 6, and the radius of the circle is 5 feet. Find the length of the arc that meets this angle. So again, you don't have to draw this out, but I like to here. So we have a circle with a radius of 5 feet, and we're looking for 5 pi over 6, which is about this much right here. So here's our angle, and we are looking for this arc length here. So lucky for us, our work is already done for us. This is already in radians. So we have S is equal to r theta, which means S is equal to r, which is 5, times theta, which is 5 pi over 6. And again, you're just going to put that whole thing directly into your calculator, 5 times 5 pi divided by 6, okay, and you're going to get 13.1 feet. Again, don't forget your units. Okay, so the last thing I want to talk about is sector area. And in general, if the angle of a sector theta is measured in degrees, then the area of the sector is A is equal to pi r squared theta over 360. Okay, and I know this is a little bit of a mouthful, but if you kind of look at what the area of a circle is, pi r squared, right? What we're doing really is we're kind of just dividing it by the sector of the circle that we're looking at. So here's our pi r squared, and then we're seeing our whatever our angle measure is over the total of 360. Okay, so if we are measuring it in radians, then the area of the sector is pi r squared theta divided by 2 pi. Again, we have our pi r squared theta, Okay, the only thing here is you can actually, we went a little big here. You can actually reduce this to be r squared theta over 2, because these pi's can actually cancel out. Again, you don't need to have the simplified version, but sometimes it is good to know that this is equal just in case you need to find something specific. Okay, so let's try an example. If this will work with me here. Okay, so we're going to find the area of a sector with a central angle of 170 degrees and a radius of 4 inches. Okay, so I like, again, to draw it out just a little bit here. So we have a radius of 4 and an angle of 170. Okay, so we're actually going to use the A area is equal to pi r squared theta over 360 degree formula. Okay, so now we have pi r squared, which is 4 squared, times theta, which is 170 degrees, divided by 360 degrees. Now, you can reduce this, or you can put it directly into your calculator to get that the area is approximately equal to 23.7 inches squared. Okay? So don't forget your units again. I cannot stress that enough. If you guys forget your units on a quiz or a test, I cannot give you full credit. So this is actually an important question that a lot of kids like to know. There are 2 slices of pizza before you. One came from a 12-inch pizza and is cut into 8ths, and the other is a slice from an 18-inch pizza cut into 12ths. So which pizza slice are you, if you're really hungry, do you want? So we're looking at 2 slices of pizza here. If it's a 12-inch pizza, okay, the radius is 6 inches. Okay, so your radius is 6 inches on a 12-inch pizza. If you're looking at an 18-inch pizza, your radius is going to be 9 inches. Okay, now the first pizza, which is 12 inches, is cut up into 8ths. Okay, and the second pizza, the 18-inch pizza, is cut up into 12ths. Oh my goodness. Try my best here. Okay. So we're trying to find the area of this and try to compare it. So we're going to kind of use the formulas that we have, but we're also going to think a little bit logically about this. So remember, the area of a circle is pi r squared, right? So the area of the 12-inch pizza is going to be pi times r squared, which is going to be 6 squared, or 36 pi. But because they're cut into 8 slices, we're going to divide that number by 8. Okay, and when we do, we're going to get that the area is approximately equal to 14.1 inches squared. Now let's look at the area of the 18-inch pizza. So we have pi r squared, so in this case 9 squared, but because we're looking at 12 slices, we're going to divide the whole thing by 12. So now we have 81 pi over 12. We can put that directly into our calculator again, and you're going to get 21.2 inches squared. Now, you have 2 answers here, but have you truly answered the question? No, because the question's asking, which pizza slice do you want? Well, now you can actually back up your answer with math. So you can say something like, I would want a slice of the 18-inch pizza because it is more. Okay, so I know today's lesson was a little bit short, but today what you're going to do is you're actually going to practice more radians and degrees, and tomorrow you guys will be practicing more sector area and arc length questions. Okay, so again, don't hesitate to contact me. I am always available through email or your Google Meets. Have a fantastic day.